have some bad news. If you sold your old phone or laptop today, could a stranger recover your personal photos, passwords, and private documents? The terrifying truth is, yes. You also wondered why deleting a massive 100GB game takes just a few seconds, but downloading it took hours. It's because your computer didn't actually delete anything, it only created an illusion. Today we are exposing how file deletion really works, why your operating system lies to you, and how to actually wipe your data forever. Stick with me to the end. To understand how deletion works, we first have to look at how files are stored. Your photos, videos, music, or documents don't just sit on thin air when you save them. They actually get written on a physical hardware called flash memory. Think of your flash memory as a massive hyper-organized warehouse filled with billions of electronic switches called transistors. Everything you save on your device gets converted into raw binary code, a long string of zeros and ones. For example, the letter A is converted using ASCII to binary and saved as 01000001. These zeros and ones are stored by trapping electrical charges inside those transistors. When a cell or a transistor holds a charge, it represents 1, and when it doesn't, it represents 0. Now for the operating system to keep track of where each file lives, it creates something we call an index. It's like a table of content that points directly to those physical memory addresses. In a flash memory, those transistors are grouped into pages, usually 4 to 16 kilobytes, which are grouped in larger blocks, usually 2 megabytes to 8 megabytes. This part is very interesting. You see, your computer plays a little trick on you. When you select a file and hit delete, it doesn't clear out those physical ones and zeros sitting in your flash memory. Yes, stay with me. Your computer simply opens its index, like the table of content, and erases what points to the file, because that will be much easier and faster to do than wiping every single 0 and 1 belonging to that file. That is why downloading 100GB game takes hours while deleting takes seconds. It's because during download, it is actually physically writing those zeros and ones in your flash memory, while when deleting, it is just removing the pointer, but the actual binary data is still sitting in the storage. You are now probably asking, if the data is still sitting in the storage, then why does the storage space suddenly shows you gain 100GB of free space? Listen, your operating system does not calculate the free space by checking physical memory for empty cells or transistors. Instead, it adds up all the space marked as unallocated by the index. So when your index ignores the place, it is as good as empty for the computer. This index guy seems to have a lot of control in your computer memory. Then, what is a file system index itself? Inside your computer, the storage drives don't understand human file names like project documentary.mp4 or sound.mp3. To fix this and make it possible for humans to find their stored files, operating system uses a file system index like NTFS on Windows, APFS on Apple, or ext4 on Linux. The index acts as a master directory and it holds two main things: the metadata and the pointers. The metadata is like the file name, the date the file was created, the file size, and the permissions given to the file, while the pointers, which is the exact physical memory addresses where the file's binary pieces live. Example, block 105 to block 112. Deleting a file removes the metadata and pointers of that file, so the operating system marks that address as unallocated. This brings us to the next question: why can files be recovered, and how can recovery software rebuild them? Since you know that deleting only removes the pointer but not the actual bits and binary code sitting on the physical memory, data recovery software completely ignores the file system index and performs a deep scan process called file carving. Almost every file type, whether it's a video, picture, audio, or document, start and end with a unique binary signature called headers and footers. These signatures are specifically for identifying the file type. The recovery software scans every sector, identifies the headers and footers, pieces the data in between together, and recreates a new index pointer, so you get your file back. Now you are even more curious: what actually destroys the file forever? If deleting only hides it, what makes it vanish for good? There are two ways data can be completely destroyed in the memory. The first one is overwriting. On older mechanical hard drives, the ones that stores data on spinning platters like a disk, this is the only way data gets destroyed completely. If you save a new file, record a video, or download an app, the operating system looks for space marked unallocated. If it picks the physical sectors where your deleted file was hidden, it writes new zeros and ones right over the old ones, and once those transistors are physically changed, the old file is gone forever. The second one is streamed on NAND flash memory. Modern smartphones and SSDs uses NAND flash memory, which cannot perform direct overwrites like older HDD platters. It reads pieces of data in pages ranging from 4 kilobytes to 16 kilobytes and erases data in larger chunks of blocks, which are hundreds of pages grouped together, usually 2 megabytes to 8 megabytes. But there is a downside to this. A block might contain 2 or more unrelated data written on it. So how do we avoid deleting what is not intended to be gone? To solve this, mobile operating systems uses trim command to erase data. This involves 3 steps. Step 1. The trim command. When you delete a photo or an app on your phone, the operating system sends a trim signal to the flash memory controller. This signal simply says, these memory addresses no longer contain useful data. Step 2. Instant address mapping. The flash memory controller unlinks those physical addresses, so if anything tries to read the deleted sectors, the controller instantly returns to zeros. Step 3. Garbage collection. Yes, just like you heard it, that's exactly what happens. When you plug in your phone overnight for charging, garbage collection physically applies an electric voltage to wipe those memory blocks back to a clean binary state. That is why files deleted on modern devices are permanently destroyed within a short time. But wait, you can just restore your files from the trash if it's still there. Slow down, genius. There is a big difference between sending a file to the trash and permanently deleting it. Moving a file to the trash or recycle bin is just moving it into a hidden system folder, or simply just changing the files folder. Only the metadata change, but the pointer is still intact and still takes up storage space. Emptying the trash is what actually deletes the pointer, making the space unallocated and free to receive new data. The files can still be recovered if those transistors stay physically unchanged. If you delete a file, you probably want it destroyed and don't want anyone to have access to it if it's sensitive. So why don't the operating system just instantly destroy the files immediately after deletion? There's actually a trade-off here. Removing an index pointer takes less than a millisecond, while overwriting a 100GB file requires physically writing 100GB of data, which spikes up CPU usage and causes your device to freeze. Forcing a full overwrite on every single temporary file or deleted document would triple unnecessary write cycles, which can cause higher power consumption and shorten the storage lifespan. Also, if a critical file gets deleted due to human error, instant destruction leaves zero room for recovery. Now, in a situation where you accidentally delete a sensitive file, stop using the device immediately, because downloading recovery software on that same device can overwrite those unallocated sectors. Then run recovery tools on an external drive or consult an expert. To permanently destroy sensitive data, do either of these three. 1. Use digital shredders. These are tools that are dedicated to overwrite specific sectors with random data before removing the index pointer, so the file is already destroyed before it was even deleted. The second one is full format drive wiping. This is different from quick format. It is the same process with how digital shredders work, except full format scrambles the entire physical state of the drive before resetting all the index pointers to default. The third one is physical destruction. If you decide, hey, you know what, I think destroying the entire drive is worth it, or for extreme security reasons, just burn or break the drive. This makes recovery impossible if done properly, because, for example, if only the external hardware got damaged and the internal components are just fine, someone can repair your drive and plug it in their computer, and tada, there goes your data. So the next time you delete a file, you'll know the truth. Your operating system didn't magically erase it, simply stopped knowing where to look. Until those physical memory cells are overwritten or permanently wiped, the data may still exist beneath the surface. It's one of those invisible things happening inside our computers or phones every single day, yet most people never realize it. If you learned something new today, consider subscribing. I've got a lot more videos like this coming, and until then, stay curious.